I'd like to introduce today's presenter, Eric Thompson, Program Manager for the Microsoft Corporation. Eric, you now have the floor.
Excellent. Thank you very much, Sarah. Good morning, everyone. My name is Eric Thompson, as Sarah mentioned. I'm a Program Manager at Microsoft Corporation. Among other responsibilities, one of the things that I work on is LINQ to Dataset, which is what I will be talking about this morning. So let's dig right on in. All right. So before digging into LINQ to Dataset, I want to talk about some of the new technologies, in fact, all the new technologies that we have coming out of Microsoft in the near future and how they relate to the overall data story and data programmability story. So you've been hearing a lot, or hopefully you've been hearing a lot about LINQ to SQL, LINQ to XML, all these new LINQ technologies, the entity framework. So a common question is how do these new technologies relate to and impact the data set? One common question is the data set being deprecated? Is it going to go away? Are we going to, is this going to be another API shift for Microsoft where we're going to move off into something new? No, we're definitely not. It's a new technology. These others are new technology, but dataset is going to be around for a long time. Does it mean that dataset's no longer going to be the poster child for Microsoft Data Access? Well, it's going to have to learn, like many of us did, to share the limelight with new siblings. But like an older sibling, it's important to remember that the benefits that time has brought to the dataset. So it does bring to mind the question of what benefits has it brought to the dataset? When do you use what? So as I mentioned, the dataset is going to continue to grow and flourish and remains the technology of choice for a number of scenarios. So some of the benefits that I mentioned about time bringing to it is the integration of things like SQL cache dependency, XML serialization, the XML integration with things like the XML data document, and the ability to have data views and calculated columns, to be able to have millions and millions of rows in memory and do it efficiently. So most of the new technologies that are that prompt these questions of the future of data set promote an object-oriented view of data access. Now this really does make a lot of sense for a lot of applications. For example, if you're writing an online game, you might want to have a sword object. And you might want to store the sword object in a database. So, you have it persisted and you have it backed up, et cetera, et cetera. Now, in addition to having just that raw data, you need to be able to do things like have the sword draw itself onto, say, a direct 3D screen, or be able to interact with other objects in the world. And that's where this object-oriented view of the world really does have a lot of benefit. So that's fine. But for a lot of other applications, having the idea of tables, rows, and columns that the data set is designed around really makes a lot more sense. If you have an orders application, you have an orders grid, that really has a very tabular type of format for which a data set is excellently suited for. So use what makes sense. As Visual Studio Orcus ramps up and as we get ready to release, there'll be a lot of talk about all these new technologies and stuff, but you have to remember that now you just simply have more technologies that you can choose from to have your application be better. So now on to LINQ to Dataset. What I want to cover is, first of all, I want to have a general introduction to LINQ, what it means, what it is. It's this term that's been thrown around. There's a lot of marketing behind it. So what exactly is it? Then I want to talk about LINQ to Dataset in particular. Finally, I want to talk about a new component that will be introduced it should be out in Orcus Beta 2 called the LINQ Data View, which will address some key scenarios that hopefully should be pretty exciting for people. Okay, so LINQ. What is it? Well, what it means is Language Integrated Query, one of these nice acronyms with random capitalization thrown in. What it means is that instead of having to work in multiple languages, T-SQL, XSLT, VBScript, in the past you've always had to, whenever you move outside of the CLR, you have to shift to another language. And shifting to that other language involves both change of mindset and a change of syntax, a change of just your whole mind frame and the way you work on problems. So what LINQ is all about is making query a first-class concept in the framework. That means you can now work in one language. You can now work in your language, C# or VB, or coming down the pipe we have Iron Ruby and Iron Python. These are all new languages that that are able to support LINQ. Now, for the Orcus timeframe, we are releasing for VB and C#. I'm not aware of any other plans to support other languages, but those are definitely plans in the works. So what does it do? So LINQ allows you to write queries that enable you to take advantage of all the developer productivity features you become used to with Visual Studio and with the CLR. Things like strong typing, IntelliSense, compile time errors. All of these have a key benefit, and that is they lead to fewer runtime errors. Think about it in the past. If you had written a T-SQL statement or SQL statement or an XSLT statement that would do something like this sample LINQ query below, where you're comparing a name to a date of birth, you would have absolutely no idea that that was going to fail. It's simply a string, or it's an object that lives in its own runtime, in its own system. So what would happen is that, if this is a corner case that maybe it wasn't caught by your testing and you weren't aware that this was maybe this query was being automatically generated somewhere, you wouldn't know that this was going to fail until your users call you up and say, hey, I got this cannot compare or type exception. What's going on here? Well, LINQ really allows you to eliminate that because everything is typed. You know what will work and you know what will not work. Does that mean that there's absolutely no exceptions? Of course not. But it reduces the number of runtime error by shifting those errors into the compiler, which is where we want them, because then it's much cheaper to fix. The other thing that LINQ does is it allows you to use familiar CLR methods and properties in your query. So you don't need to learn another syntax for substring. You don't need to learn another syntax for split, for all of these really common operations that we need to do. And yet all the different languages and all the different query systems and languages and syntaxes all have a slightly different format. So this allows you to, we know how to do it. We know how to say, for this example, for Washington contacts, for customers, where the state starts with WA. We know how to do it in the CLR. And now LINQ takes care of the work of making sure that it works in your target, or what the target of your query is. This slide is a little bit disjointed. Please accept my apologies if it doesn't look correct. So what LINQ does is it provides a common language. It provides a common set of verbs. When I say common language, I really need to specify that and say it's a common set of verbs. So we have things like where, join, order by, sum, etc. There's a really good, on MSDN, there's a really good resource that shows you all of the standard LINQ operators or LINQ verbs. So does that mean that all queries are now equal? You don't need to know what you're querying, you just need to know the verbs and you just write it and away you go? Definitely not. Like anything, we've given you power. There's a lot of power in LINQ, and there's a lot of power to hang yourself. If you do a join, and one of the targets of your join happens to be a web service, so for every single join operation, you're calling out to a web service, which is going to go all the way out to the web and then come all the way back, your performance is going to be less than stellar. So while you still need to be aware of the underlying technologies, LINQ allows you to no longer have to worry about the syntax, no longer have to worry about the structure. So it provides both that advantage as well as the typing. Again, remember that as a language, LINQ provides a set of verbs, a set of actions. The nouns, you still have to know. And nouns make a lot of difference. You have, for example, you have something like water. Water runs. And a politician runs. Same verb, but are they really the same thing? Not really. Aside from the fact of both going downhill, the nouns make all the difference. So just be aware of what LINQ buys you and what LINQ does not buy you. All right. So LINQ has two dialects. We have the first one. Now, as a language, languages have dialects. The first one is a query expression. And this is the one you're going to see most often, and is really the one you'll probably use most often. And this looks a lot like SQL. Well, a little bit like SQL, a little bit mangled SQL perhaps. Things are a little bit out of order. Maybe it doesn't make total sense. But basically, it's got the same type of structure. So for example, we have var query. Now, when I mentioned the var keyword, this is a new feature of C#9, or sorry, C#3, and then there's an equivalent feature in VB9. So I would recommend going to MSDN and looking for information on those. It's a really cool new feature that will be coming out with Visual Studio Orcus. Not required for using LINQ, but very helpful. So you're saying var query equals from order and orders. So that's kind of like it's your from statement in a SQL statement, where order.id equals 1, 2, 3. It's simple, it's a where statement. And then the select comes last, where you're saying, now I want to select the order. Now that's kind of weird. It's like almost saying you're selecting the table. So it's not quite analogous to SQL, but the syntax is at least similar. Now there's a second dialect. So this one is called a method query. And that's because it looks like method calls, because that's exactly what it is. So the same query as we showed on the last slide, it would look like this in a method query. So you say orders, where, and then this is we reuse this new lambda syntax, which again I refer you to documentation for C#3 and VB9, where ordered ID equals 1, 2, 3. Basically all it's saying is that it's like think of it like a delegate for right now. And then you're saying select, give me the order. So those are the two dialects. Now, while they are two dialects, they are the same language. Both the query expressions and the method queries ultimately compile down to the same IL code. Now, that doesn't mean that you can always translate easily from one to the other. The query expressions are language dependent. So that was the SQL-like one. So VB has a wider variety of query expressions than C# does, and a different set. You know, it handles some aggregate functions a little differently. So those are really where the languages come into play. So you can't always take a query expression and mentally convert it over into a method query back and forth really quickly. So that's ultimately what it is. Why do you want it? Well, productivity. This is going to give you a huge productivity boost. I can tell you personally, just writing little sample applications, and for my personal life I like to write applications, and LINQ just makes things so much easier. As soon as you have IntelliSense, as soon as you have compile time checking, it just makes things easier to do. I don't need to learn new syntaxes when I need to do XML, for example. I don't need to learn XQuery syntax. I just use LINQ to XML. And I can't tell you how many times, I'm a horrible speller. I can't tell you how many times I misspell something. And how many times I misspell something in a string, like a SQL string. And I don't find out about it until runtime, and then I got to go back and I got to fix it and restart my whole debugging process again. It's just such a headache. This eliminates that. And how it does that is through the typed queries. So everything is typed. Now that doesn't mean you're forced into typing. And for VB users, you can still use the implicit typing, but it is still typed if that option is there for you. And it's more expressive. So it's up to the LINQ providers to create a translation from what you would write in LINQ to the target. So it's expressive in that what you can express in the CLR is an enormous amount, and translating that to the target is something that you no longer have to worry about. It's something that the platform writers have to worry about. All of which leads to better code with fewer errors, which is ultimately one of the great things that we want and things that have helped us. So I'm going to take a quick moment here and just answer a couple of questions that came up. One of them was asking, with the advent of LINQ, does this mean that I can forever forget godforsaken SQL? Well, no. I should say maybe. It will help for a lot of situations. A lot of times, SQL queries that you write are very simple. Now, first of all, I should also say that this webcast is about LINQ to dataset, which I will be getting into in just a moment, which doesn't actually interact with SQL much at all in the sense of where this technology is focused. In a general sense of LINQ in general, you will still need to know SQL in certain situations for complex queries, for high performance. For the most part, if you're doing simple operations, you probably can get away without writing much SQL. So I hope that answered your question. So another question is comparing the performance between LINQ and T-SQL. That is a whole nother webcast. It's a complicated, nuanced situation. LINQ as a technology, and then so LINQ as a technology is the querying language. Then you have LINQ to SQL, LINQ to entities, LINQ to datasets, LINQ to XML. All of these different technologies work differently. There's a common idea that LINQ is only against SQL Server, or only against a relational store. As is illustrated in this webcast, it's actually, you can write LINQ against a dataset. You can write LINQ against probably virtually anything, any sort of a data source, as someone writes the provider for it. So let's move on to LINQ to dataset. All right, so where does it fit? Where do you use LINQ to dataset? Like what part of an application does it fit into? So from a high level, if you think about most applications have some sort of a data store. It could be SQL Server. It could be a web service using WCF. It could be an XML file on disk. It could be virtually anything, some source or store of data. Now you load that data into the data set. Now from the data set, you then use that data in, say, a UI or a middle tier, an ASP.NET application, a WPF application. There's all these new, and now, with these new announcements, all these new technologies that you would use the data in. So where do you use LINQ to dataset? Use LINQ to dataset to get data from your dataset into the consumer of the dataset. So it's not about loading the data from the data store into the dataset. We have a lot of great technologies for that, and there'll be more coming out in the future. But what the LINQ to dataset is about is querying against the dataset. So what we have is now we have a full-featured language for the dataset. This has been a common request since the initial version of the .NET framework. The dataset is this really cool technology, but while there are some really neat ways to query the dataset, it's always been not quite enough. People have always wanted to do a little bit more. Probably says something about the nature of people, but it's a very valid request. So now we have a full-featured query language. And due to the in-memory nature of dataset, the full CLR feature set is available. So anything you can do in the CLR, you can write now in a query. And I'll have some cool examples of that later. So this means that it's full LINQ support. Everything that you can do, all the LINQ operators are supported. And if you can dream it in LINQ, you can write it in LINQ to dataset. So a good way to kind of show what LINQ to dataset is and how LINQ to dataset works is to actually just dive into some samples. I think that's always a good way to go. So the samples I'm going to do a simple join, because a join is a very common operation. I'm going to show kind of a neat cross-domain feature of LINQ with join to UI. And then I'm going to show some data binding stories with copy to data table and LINQ data view. Now I will make these samples I'm going to post them up on my blog after or sometime later today, and I'll provide the address for that at the end of the session. So it wouldn't be a Microsoft webcast without AdventureWorks or Northwind, but today we're using AdventureWorks. So the database portions of AdventureWorks that we're using are the sales-based portions. If you've ever looked at AdventureWorks, it's a big, complicated schema. There's got a lot of data in it, and we're just looking at a small subset of that for today. So, simple join. This is one of the most common requests for a data set. You know, you have an order header and you need to join it to an order detail. We've always had this idea of a relationship, or a data relation, which fulfills some of the requirements of a join, but it doesn't have the same querying mechanism. It's more for a one record at a time view of things. So, with LINQ to dataset, we now have the ability to do a join. So I'm going to show two joins in here. I'm going to show a simple join using the query expression, which again is going to be the way that most of you will interact with LINQ. Then I'm going to show a little bit more complicated one that uses a method query. So you can kind of get a taste of both dialects. And with that, I'm going to jump into the demo. All right, we'll see if this works. Perfect. So, what we have here is we have this is a interim build of Visual Studio Orchis, so please bear with me if things don't work quite right. It's very, very much in beta alpha status. This is not at all even what's been released. So we have sales order header, sales order detail, and we have our two queries. I'm just going to bind them to a form, so I won't show the form. Now let me make sure this is, can everyone see that form? It's showing up as gray on my screen.
Yeah, oh, there it goes.
It's, yeah, I'm not.
Yeah, oh, there it goes.
I'm seeing this, I'm not seeing the, let me, okay, I think I know what the problem is here. Let's do, okay. We'll see how this works. Okay, so this is the application. I'm going to have to do this a little ad hoc in here. So basically we have the two queries and an orders view. So it's of somewhat interest, but I'm going to actually switch back to the code view so we can actually just look at that. As you can see, this form just simply is going to display the results of the query. I'll still show it to you to prove that it works, but it's not the interesting part. So we'll jump over to the Visual Studio, and then we fire it up. So execute the first one. Now this is the query expression. So what this is doing is this is saying from the orders in the sales order header, join the order details and the sales order detail on order.sales order ID equals order detail.sales order ID. So it's very similar to what you would do in SQL. You know, you're joining a parent to a child table. So some of the interesting things you can see in here is that we actually have a new equals keyword, and we have this new syntax for doing these query expressions. And then now we're saying, okay, we want to have some restrictions. We don't just want a plain join. That's kind of boring. So we're going to say, okay, let's look at where the total due on the order is greater than 10,000, and where the order detail has a unit price discount greater than 0. So we want to find, you know, big purchasers that have a discount, or that have a unit price discount. And then what we have is we have the select statement. Now, in the examples that I had shown in the slides, we were selecting the entire object. Well, a lot of times when we're doing a join, we're going to want to select some things from the parent table, some things from the child table, or the master table and the join table. So we're using this new feature called anonymous types. Anonymous types is a new feature in C# 3 and VB9. Again, I highly recommend reading some material on both that and some of the other new language features I've been talking about. And this is basically saying we're going to create a new type which has an ID, which is going to be the sales order ID, the account number, the order due, or the total due, and the unit price discount. And then we're going to just take this query and we're going to assign it to the data view. So we just run it through. And jump back over to my application. And you can see here's all the records. Now, we'll take a look at the second query. So the second query is a little bit more complicated. So this we're going to do some grouping. We're going to use something called the group join operator. So this is where kind of the simplicity of the query expressions that I just previously shown really kind of shine. And you can see, while this looks a lot more complicated, and while it is more complicated, once you get used to the syntax, it's not as ugly as it appears. So what we're doing here is we're saying from the sales order header, we're going to group join the sales order detail, and we're going to group join on the sales order ID equals the sales order ID. And then we're going to get this new header and details. And what this is a group. It's like a dictionary, where you get a dictionary for every header that contains all the details, or a list for every header that contains all the details. So like a list of lists, so think of it. And then we're going to select out the sales order ID from the headers, the total due from the header, and then the count of the item, the order details, and the average of the unit price. So like a SQL aggregate query, you need to structure it just right so it will work. You need to select only those attributes that you are grouping on, and then any aggregate functions like count or average against the items that you're grouping. It sounds confusing. It's pretty straightforward when you look at it from a SQL perspective, or from this perspective once you start working with it. And then we're going to have the same criteria. And then we're going to say where anon. Now I say this because this is a new anonymous type, where the total due is greater than 10,000 and the item count is less than 10. And then we're just going to select the anonymous type. So this is going to select a new anonymous type with the sales order ID, the total due, the total number of items in the order, and the average unit price. So we'll let that run. I will jump back out to share the actual application. And there you go. You can see the results. So that kind of shows a good couple of examples of how you do queries, how you do simple joins. Let me jump back to the slide deck. Okay. So let me just answer one question here. Do you have to declare your query object as var, or is there a strongly typed object you can declare it as? So you can declare your queries as strongly typed objects. Now var is a strongly typed construct. It appears to be like it's not strongly typed, but actually what var says, all var does, is it says, compiler, figure out the type for me. That's all it says. So it's still strongly typed, it's just letting the compiler actually figure out what type it is. Now, you can't declare it as a strongly typed query unless you're using anonymous types. Anonymous types are anonymous, which means that you can't actually declare a type of anonymous types. You have to use the var keyword if you use anonymous types. So if you're just selecting a string or an integer, definitely you can use an explicitly cast variable or explicitly typed variable. Okay, so let's move on. Sample 2. This is a join with a little bit of a twist. So this is where I'm going to show how LINQ can be used across domains. So actually, let me back up a quick moment here. So I wanted to talk a little bit about why doing that, why those joins were important. why doing the joins that I just did the sample ones. So as I mentioned, I'm always bringing back to, okay, well, it's kind of this is the way you would do it in SQL. So why wouldn't you just do it in SQL? And SQL Server is a well-established product. There's a lot of history and time behind it, a lot of testing. It's a great product. Well, if you've used Dataset, you know that there's this really cool technology like with table adapters and the wizard-generated code and the ability to create new stored procedures, the ability to have your dataset basically represent your database. And that's really handy, especially for doing change propagation. So you make a change, and then now you can persist it back to the database. As soon as you do the join on the server, you now have to write custom logic to do all of your updating. So by doing the join on the client, you negate the need to have all of that custom logic on the server or in the data adapter or the table adapter, depending upon what you're using. So it really does make things a lot easier and a lot faster to write. With that said, does that mean you want to bring your entire database over in a data set? Well, depending upon your situation, perhaps, but probably not. So this is where joins really come in handy with the data set and really will make your life a lot easier. So with that, let's move on. So this is a join with twist. So as I mentioned, LINQ can be used across domains, with the knowledge that if you go across domains, you have to be aware of what's going on so you don't shoot yourself in the foot with performance. So what's the twist? So what we have is we want to show all of the products for a set of categories we select. Not one category, but a set of categories. So if you've ever written this type of query before, it's not really a complicated query to write, but it's time consuming and it's error prone. You need a loop to get each of the selected categories, then you have to go over each of the selected categories, you have to get all the selected subcategories, and then for each of the subcategories you got to get all the products. It's this kind of nested loop, and it's going to probably be inefficient, it might be slow. I mean, if you don't write it right, you're doing a n-cubed operation, it's just not fun. So, not great, but remember with LINQ, we can now mix and match. So, let's say you have a text box, or a checkbox list with your categories. You want to show the product. Well, because we're in the CLR, LINQ is a common language that can be used in the CLR. We can actually join to UI elements. So checkbox list, data grid views, buttons, whatever. Anything that's queryable, anything that implements iQueryable, you can use LINQ on. So let's take a look at that. So, stop that last one from running. Now this sample, it is in Visual Basic, and the schema that we have for the data set is the same schema that we were showing, that I'd shown on the slide. Product, product subcategory, and then down to category. Now, the form, let's fire this up and show you here. Okay, so this is the way that the form looks. We have in this case, it's a data grid view with the different categories, and then we have where we're going to show the products. So let's say we want to see the accessories and the components. Now let's click show. There it works. Now let's actually see it work. One moment here. I switch around. Excellent. Okay. So now we're selecting components and accessories. So now what happens is I actually split this into 3 queries. You could do this in one query, but there's absolutely no reason to. It's just as efficient to do it in 3 separate ones as to do it in one. So what I'm doing is I'm saying from the data grid view, get the rows. Now I'm having to cast it as data grid view row because it's not a strongly typed collection. And I'm saying where the checkbox is equal to true. And I'm saying, give me the data-bound item, which in this case is the data row view. And then I'm saying, and then assign that to selected rows. And then I'm saying, for all the categories in selected rows, get me the subcategories from the product subcategories, where the category ID equals the subcategory product category ID. Now, normally you would use a join in this situation. However, the join syntax is still coming in Visual Basic, and it's not quite baked in just yet. So you can also use these two froms, which in essence does an outer join, and then you select the, or you restrict the join based on your where clause. So then you're selecting subcategories. So now you have all your selected subcategories. So now you take your subcategories and you join your products. You also select your products from your data set. Now you have to check to make sure that the product subcategory equals null, because you can have products without a subcategory. And null exceptions, the way that nulls are handled in data set is very similar to the ways that nulls are handled elsewhere. So you still have to check for nulls. And then you're saying where the subcategory ID equals the selected subcategory, product subcategory ID, select the product. And that gives you your matching products. And then you just bind it to your grid. So I'll just let that continue to run. Jump back to the form, and you can then see the results. So if you wanted to also show clothing, you can do that. Just zip through that. Shows you now the clothing as well. Let's say you only wanted to see the bikes and the accessories. There's the bikes and the accessories. Now in this situation, we're only selecting the products. So these are all the products on the grid here for these categories. So we're not doing any sort of an anonymous projection. So in this case, referring to the question about the typing, you could actually type this as a query of products instead of having a var. Now the dim in VB works the same way as the var in C#. So think of the two as analogous. So let's move on here. So the sample is, I think the sample is really cool. I mean, when you really start to think about what you can do now when you can join UI elements in a query to data set. I mean, this is going to eliminate a whole host of code. I mean, especially when you have things like checkbox lists or anything where you're selecting multiple items. It's really handy to be able to use that group of items and that selected group of items as a source of a query, which then you can join to a data set or you could join to an XML. So this really worked well because everything is in memory. Now, other LINQ flavors like LINQ to SQL or LINQ to entities, or sort of if we had LINQ to Active Directory, for example, may not allow this type of cross-domain queries simply because that there are serious performance implications. As we were going through all of those queries to select the selected categories and then the selected subcategories and then the selected products, if you had to go out for the categories to a web service, you can end up going out to a web service far more often than you want to. You could be a serious performance impact, and you would not necessarily know that it was going to be bad. So be aware of performance implications. With LINQ's data set, there are none. Because it's all in memory, you don't need to worry about it. And so you can really do some cool things joining to the UI. Okay. So one of the big disadvantages of LINQ to dataset is the GUI binding story. So as you saw, like with that previous example, I was selecting the products. Or with my initial sample, I was selecting this new anonymous type, this projection. So what exactly are those? Well, in the projection, it's this list of anonymous types. So you bind it to a grid, but what happens when you update the grid? It's updating this anonymous type. Or in the second sample, you're selecting this list of, what it comes back is a list of data rows. Not as part of a data table, just a list of data rows. So you can update the data row, but what are you going to do with that? It's not part of a data table anymore. So this is one of the hiccups in working with LINQ to dataset, is that there's one-way projection, there's no round trips to the data source, and when you update data in the data set, it doesn't appear in the results. Well, that is one of the problems, but there are ways to work around it. One of the ways to do that is copy to data table. So it allows you to move the results of a link to dataset query into a data table. Now this data table can then be merged with the source. It can be updated. It's a fully live, active data table with the same schema as your source. So while if you update the source data set, it won't automatically update your LINQ query results, you will be able to, say, merge it back in or send it back through a data adapter or a table adapter to the database to be updated. So how does it work? So as I mentioned, LINQ to dataset queries are from a sequence of data rows, generally, or anonymous types. So copy to data table moves these into a data table. Now, as I mentioned, that it doesn't work for absolutely everything. And we're addressing these holes in the Orcus time frame, sort of figuring out the best ways to get as many scenarios where you do a LINQ query into a data set as possible. So I'm going to kind of show you how this works. So now this sample is additionally in VB. And what we have is we have a customer and a sales order header, which is basically the sales, or an order, I mean. So in code, what we're going to do is we're going to initially bind to a grid. And what we're going to bind is all of the customers that placed an order in 2004. So I'm going to fire that up and let you see. I need to set the startup project. So as you can see, we're going through and we're saying from the customers, and then from the sales order headers. So this does an outer join, and then we're saying where the order date, the year equals 2004. So this shows right here a cool example of why LINQ is useful. You don't need to figure out how to extract a year from a date. I mean, there's a lot of different ways to do that. SQL has its own way to do it. Access.c has its own way to do it. You can just use the CLR way to do it. And then you're saying, and also the customer ID equals customer ID, your join criteria. And then now you're selecting a customer. So that's ultimately what you're interested in. Now, as I mentioned that this was an outer join here, in forthcoming versions of the betas, of the Orcus betas, there will be a full join syntax, which will actually improve your performance for these types of joins substantially. So jumping back to the application here. Okay, you can see these are all your customers. Well, because AdventureWorks is such a highly normalized database, it's kind of an ugly grid. But let's say we wanted to change the account number on this for this customer, and we changed it to 7. Well, now what we want to do is we want to actually show the changes. So let's click. Let's see what happens when it updates. Okay, so as we go through here, we can see so we're getting the data source as a data table. Now, what we're doing is we're saying we're going to, because when we bound the grid, we actually bound it with copy to data table. So this returned a new data table with the same schema as the customer table because we were selecting customer rows. And so we created a new copy, the schema copy of the customers table with the records from this query, from the LINQ to dataset query. And we made that into the data source of the data grid view. So now we're getting this data table back out. We're merging it back with the original customers. So now we have the same as if you had done the restriction in some other way aside from LINQ and directly edited the data set. So now what we're going to do is we're going to use LINQ again here to actually call get changes on the customer data table. And then we have to call it as enumerable because by default the data table is not enumerable in the way that LINQ needs. And then we're going to select the change. And the change in this case is a data row. And then we're just going to say for each data row, we're going to show a message box that the data row changed. In this case, we only have one change, so we only loop through the changes once. And there we go. So now you could take that. So now you could take this changed table, this customer table, and send that with your SQL data adapter or with your data adapter or table adapter back to the database, and it would update correctly. So you have to go through, it's a little bit more complicated than just simply being able to join and arbitrarily update the results. Unfortunately, this is a problem that's systemic through all of the LINQ implementations. Anytime you do a projection, the update story becomes a little bit more complicated. So, is that the best we can do? Well, no. That is a very good way to work around the problem of data binding. But we have another option where you can have your cake and eat it too. So we have this new component called the LINQ data view. So as you may be familiar with the data view as a way to do sorting and filtering against the data table using the string-based expressions in the current version of the .NET framework. Well, this is a subclass of the data view that is actually created from a linked dataset query. It's fully bindable, fully updatable, reflects changes in the underlying data table. It works exactly the same way a data view does today. So the sample I'm going to show to illustrate this is you have an order fulfillment center, and you need to figure out in which order to ship packages. Well, key observation is that for a given class of carrier, for ground or air, what have you, the further away a package needs to be shipped, the longer it's going to take to get there. And being a customer-centric company, we want people to get their packages as quickly as possible. That means you want to ship the packages as an equitable way as possible. So you want to ship the ones that are furthest away first and the ones that are closest last, so that everybody gets their order in approximately as close to the same amount of time as possible. Well, which orders are those? You could use some cool GIS package. I'm sure there's a lot of components out there. But, there's one that we've already paid for, zip codes. So they're public domain databases that have zip codes with the latitude and longitude of every zip code, or the center of every zip code. Very cool. But how do we get the distance between the zip codes? We have the latitude and longitude, but how do you get the distance between it? The equation is not really pretty, because the Earth is a globe, we have to do all this funky stuff, and we have to convert things into blah, 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 blah. It's ugly and not anything you'd probably want to write if you could avoid it. The C# version is better. It's still a little bit ugly. As you can see, I'm using this new thing called a func, which is a sort of a variable that represents a function. But we go through, and so now we have this equation that gives us the distance, given the latitude and longitude. So let's bring it together. We want to have this. Let me fire up the application and demonstrate how this works. So let me make sure that we have a breakpoint set. Good. So what we do is we load up the sales order header and the address for all of the orders. Now the address we need because of the zip code. And then what we do is we go through. Let me just start this up and share the application so you can see what it looks like. Okay, so you can see these are all the orders. Now this is a data view, the traditional data view, and it's sorted in the order that the records were returned from the database by, which in this case is simply sales order ID, the order sales order ID. So now we want to sort by the distance. We want to sort by the distance to zip code 98006. So click sort by distance. Let me jump back over to Visual Studio. Okay. So now you can see our query. So our query is saying for all the rows in the sales order header, now we have to actually use the untyped data set in this case. The typed data set is still something we're making work with the LINQ data view. We're going to get all of the rows, all the sales order headers, and then what we're going to do is we're going to find the distance. We want the distance between this zip text box, the text of that, which is 98006, and then the ship to address postal code. This row.getParentRow, shipped address postal code, etc. And we want it in descending order. So, and then we're going to select the row, which is the sales order header. So we go through and we're saying we want the LINQ data view. We're going to do this query and we're going to convert it into a LINQ data view. Now what happens is that it's going to go through and it's going to say, okay, we need to sort this list. We need to sort this data view. And we're going to sort it based on this function. And this function is a distance function that takes zip1 and zip2 and figures the distance. So now we go through and we get the two locations. We find the two latitude and longitudes. And then we go through and we walk through that calculation that we had. And we return the distance. And it will do this for every comparison that it needs to do. Now, LINQ is a pretty smart implementation. It doesn't do a bubble sort. It does a very efficient sort. It's a very tight sort. So it will actually be about as fast as it could be as if you'd written it yourself. And a lot less bug prone because writing complicated sorts can be very ugly to do. So we go through and we won't step through every one of these. And then we'll jump back out and see the results. So now what we have is you can see the order has changed. Now what we have is this is the order of all the orders sorted by the distance to the zip code 98006, where the zip code was in this other related table. Now we could have actually used LINQ to also get the related table zip code by doing a little sublink query. I just used the get parent row for illustration purposes, but you can use LINQ anytime you would use the get parent row or get child rows. So this is a really cool new technology. So this allows you to use a data view in the same way that you would use it today, but have a tremendous amount more expressive power. You now have the full functionality of the CLR to do your filtering and your sorting. This isn't just sorting. You could have your filter. You could filter by any arbitrary function that you want to have. Be careful, because remember this is going to be executed a lot, especially for a large data set. But you have a lot of power there and a lot of expressiveness. So that kind of brings it together. So what LINQ Dataset does is it brings the power of LINQ to Dataset. It allows you to have now a full querying language to move data from the dataset to your application or to the consumer of your data. And we have a lot of power and a lot of different ways to do things that we've never been able to do before. We have LINQ Data View, which is a way to use the existing data view functionality and the existing way you would use data view in a new way. And then we have a lot more. There's a lot more you could do with LINQ to Dataset that we're not going to go into today. So some of the additional resources, I highly recommend the MSDN website, especially for some of the new language features in VB9 and C#3. If you download and work with the betas, please ask questions and provide feedback on the MSDN forums. I will post my email address and blog address at the end. Or Sarah, should I do that on this slide here?
Sure.
Okay. So my email address is erict@microsoft.com, and my blog address is blogs@msdn.com/erict. So please feel free to send me email. Like I say, I'll be posting these samples to my blog later today. Now be aware that some of the functionality may not work with the current Beta 1 bits, especially the LINQ data view. I know that will not work. The other ones should all work, although you may encounter some hiccups, so caveat emptor. So, questions and answers. Please ask me some questions and I will see what I can do. All right.
All right, thank you, Eric. I'd like to take a quick minute to share some additional resources for the Microsoft Office Live meeting. As Eric mentioned, we will begin our final question-answer session in just a moment. So once again, you can ask a question by typing the question in the question answers pane and by simply typing in ask. And to view a replay of today's live event or to register for upcoming webcasts, please visit microsoft.com/webcasts. Now would be a great time to print a copy of today's webcast PowerPoint by simply going to File, the menu bar, and click on Print to PDF. We'll also be providing a survey for today's webcast in just a minute. Please take a few moments to complete the survey. The feedback and comments that you provide allow us to create better webcasts for you. And also by attending the live webcast and submitting your survey, you'll be registered to win the Zune digital media player, which you can now see on the screen. And give me one moment while we get the survey up there, and there it is. So please follow the links provided in your interface. Take a few moments to complete today's webcast evaluation. And I will hand it back over to Eric to answer any questions.
Thank you, Sarah. So I think I'm going to answer these verbally instead of typing them out. I think it will be easier. So one of the question that I just posted there, if the LINQ statement was written referencing certain fields in the table, and later the table gets redesigned and the field name is changed, will the next compiled application detect the field name change and produce a compile error? If you're using a strongly typed data set, yes, it definitely will. It's going to say, I can't find this particular field or this particular table. If you're using an untyped data set, you actually will not get a compile time error because it does not know which fields there are at compile time. Question earlier is that is LINQ just a query facility? Can you update through LINQ? I think I addressed that. It's updating LINQ queries is a little bit more complicated topic. As it is with SQL as well, you can easily write a SQL query that you can't directly update from. So think of it in sort of an analogous way. So there's a lot of questions, I think, on the var keyword. I would really recommend going and looking for some information on that on the MSDN website. There's some really good articles on the var keyword and how this new how the new anonymous types work in C# and VB. And they're going to be able to do it a lot more justice than I will in a short amount of time. Okay, so can you tell us a little bit about the future of load sequence into data table? Perfect question. Excellent question. So we have the copy to data table. And right now in the current bits, or the current bits that we're working on, you have to select the entire data row. Copy to data table requires a query that returns a data row. With the, we're planning right now to reintroduce to data table and load sequence in the form of a copy to data table that actually will copy an arbitrary sequence. So if you do a join projection, you can now load that into a data table, which then you can update and manipulate as you will. Now you will not be able to merge that back into your source data tables, but you will be able to load it and use it the same way that you would use a data set today. Another question, does LINQ take the place of stored procedures? Well, it doesn't really impact LINQ to data set because LINQ to data set only deals with the part of the application that goes from the data set to the application. But with that in mind, in general, does LINQ replace stored procedures? No, definitely not. Stored procedures are valuable for a whole number of reasons. And some of the reasons become less compelling with LINQ, but definitely not all of them. So there's definitely still a place for stored procedures. All right, well that's all the questions that I have. So if you think of any other ones additionally, please feel free to email me. And I hope that this webcast was helpful and educational for everyone. Thank you very much for coming.
All right, thank you so much, Eric. And again, as he mentioned, if you have any further questions, feel free to go ahead and email him. And thanks again, everyone, for attending. That concludes today's webcast. You may now disconnect from the audio portion of this conference.